The last video used inheritance to derive a student class and an instructor class from a common base person class. This video will introduce a new class called teaching assistant. The teaching assistant is like a student in some ways because most teaching assistants are graduate students. However, a teaching assistant is also like an instructor in several ways. So we want to have access to the methods possessed by both of these classes as well as the method in the person class. But the way that we do this will be very different in different languages. C++ explicitly allows multiple inheritance, meaning that any class can directly inherit from multiple other classes. Therefore, the teaching assistant can be a student, and it can also be an instructor. However, this particular pattern of inheritance is problematic. It is known as diamond inheritance because we have one class inheriting from two classes which each share a common base class. And so the problem inherent with diamond inheritance is the question of which version of the name method the teaching assistant class will use. I'll answer that and other questions with source code in C++. Because C++ directly allows multiple inheritance, it is easy to adapt the code we worked on in the previous video to add an additional teaching assistant class. The list names function is the same, the person class is identical, the student class is identical, and the instructor class is identical. All we need to do is add a new class. That new class is teaching assistant. However, because we are inheriting from multiple classes, we now list them separated by a comma. We do a public inherit of student, comma, and then a public inherit of instructor. Within this class, we define a public constructor. So the teaching assistant class requires us to specify the first and the last name of the student as well as the student's graduation year. And then we call the constructors for both the student class and the instructor class. For the student, we provide the graduation year as the third parameter. And for the instructor, we hard code a title of instructor as the third parameter. The only other thing that has to be added is a way of overriding the name method. In particular, this method needs to be overridden because it is defined in the person class. Both the student and the instructor have their own versions of this method, so it is unclear which one would be used if we did not override it. We will choose to use the version of the name method that is in the instructor class, as indicated here by our use of the scope resolution operator. We can now construct a test for this new multiple inheritance example. The first part of the test remains the same. We define me as a person, an undergraduate student, and an instructor, but we add a definition of me as a teaching assistant. So this is the year I graduated from graduate school with my PhD, and we add some courses that I was enrolled in as a graduate student, as well as some courses that I taught as a teaching assistant. We can then print my name, my graduation year, and the classes that I both was enrolled in and taught. When we execute this code below, the first part is identical to what we had in the previous video, but we have this new section listing me as instructor Jacob Schrum, class of 2014, with this list of classes I was enrolled in and this list of classes that I taught. The fact that C++ allows diamond inheritance made this example easy to write by simply modifying the previous one slightly. The only chance for ambiguity was in the name method of the teaching assistant class. That is a risk that the designers of C++ were happy to take. However, it can lead to some serious issues in larger programming projects when diamond inheritance is allowed, which is why it is often not allowed in other languages. However, restricting the use of diamond inheritance has a cost, as we'll see in the next example using Java. Java allows for a restrictive form of multiple inheritance. We already saw that Java uses the extends keyword for single inheritance. And in this diagram, these black arrows represent uses of the extends keyword. For our new teaching assistant class, we must pick one of those two classes to extend, and we will make that be the student class. But because we are extending the student class, we cannot also extend the instructor class. However, Java has a special type of entity known as an interface. An interface is like a class, except it contains no definitions for its methods. It is merely a list of method signatures. In order to distinguish them, I will write interfaces in red. This is a new interface named teaches. So any class which represents an entity that teaches classes should inherit this interface. In fact, we see that the methods listed in the teaches interface are list taught courses and add taught course. These are the same methods already possessed by the instructor class. Now, the instructor class will still have to provide definitions for those methods, but they are expected in the class by virtue of the instructor implementing the teaches interface. Yes, implements is a separate keyword that Java has to designate inheritance of an interface. The teaching assistant class will also implement the teaches interface. However, a consequence of this is that the teaching assistant class will also have to provide definitions for the list taught courses and add taught course methods. This diagram now denotes how inheritance will be handled in our Java program. Now let's look at the source code. This Java source code starts off similarly to what we had in the previous video using single inheritance. We have a public static method for listing the names in an array list. We have a person class that contains a first name and a last name, has a constructor, and has a name method that returns that name. The student method is also mostly the same. We extend person, we have a class year and classes enrolled list, a constructor, as before, a way of accessing the graduation year, a way of adding a course that the student is enrolled in, and a way of listing those courses. Note that here, as before, we call super.name because the normal version of the name method will list the graduation year of the student, but we only want to list the name without the year before listing the courses that the student is enrolled in. However, there is a slight change in the name method here. We actually have two versions of the name method. Recall that Java allows for method overloading. That means that two different methods can have the exact same name as long as they accept a different parameter list. This version of the name method has no parameters and is in fact the one that is overriding the version of the name method in the person class. However, we've added an additional name method here, and this is purely to support a distinction between a pure student and a student that is actually a teaching assistant. We do this via an option, a Boolean parameter, that indicates whether or not the year should be displayed. So this method will return super.name, which is simply the first and last name. And then if that Boolean parameter is true, we will concatenate a comma in the class year. Otherwise, we concatenate an empty string. So the default version of the name method inside of the student class is to call this variant of the name method with true. In other words, the default version of the name method will include the class year. However, we also want to have a way of getting the name without the class year being shown. This will be required in the teaching assistant class, as we will see momentarily. Note also that this method is protected. This means that it is accessible to descendants of this class, but it will not be evocable by other users of the code that have instantiated student instances. Moving down, we see our interface. Now, once again, we make this static because we are putting all of this code in a single file named Diamond, but typically you would have an interface defined inside of its own file, in which case the static designator would not be required. But this is a public static interface named teaches, and all it does is list the method signatures for the methods that are required of any class that implements the teaches interface. Then we have instructor class. The instructor class extends person, but also implements teaches. Otherwise, it is identical to what we had in the previous video. We have the job title and the list of classes that the instructor is teaching. We have a constructor that evokes super first last, that is the person constructor. We define the job title and the classes teaching list. We have a way of adding courses and listing those courses. We simply evoke name because in this case we do want to add the title of the instructor, and that overridden name method is defined here. And all it does is it appends the job title before the name, which is defined inside the person class. Next we have our new teaching assistant class. In Java, you can only extend one class. And as we had in our diagram, we will extend the student class. But we will also implement the teaches interface. Note that we can implement as many interfaces as we want. If we wanted to implement more interfaces, we would simply separate them with commas here. But because we are only implementing the teaches interface and not extending the instructor class, we have to duplicate some of the code that was in the instructor class. Namely, we have to have our own version of the class's teaching list and our own version of the add taught course and list taught courses methods. These are identical to what we see in the instructor class. Because these methods are fairly simple, it makes sense to directly repeat the code. However, if we wanted to copy code that was much more complicated, then we would probably seek out a better solution, such as defining a static version of this method that accepted more parameters, and then have both versions of the class call that static version of the method. Note here that the constructor for the teaching assistant class calls super first last year. Because we are only extending the student class, this means that this super constructor call is for the student class's constructor. Finally, we override the name method. In the C++ program, we sent the string instructor in the constructor because we wanted to assign the word instructor to the job title of the class. Here, we are simply hard-coding the string instructor because every teaching assistant will simply be referred to as an instructor. But we do not want to list the graduation year of the student. This is why we call super.name false instead of simply calling super.name. Super.name is the version of the name method defined in the student class. If we called the version that did not accept a Boolean parameter, it would list the graduation year of the student. However, because we added a special version of this method that accepted a Boolean parameter, we are able to call that instead. Having defined these classes, we can repeat our usual testing example. The definition of the person, the student, and the instructor are the same. All we add is a definition of me as a teaching assistant. The constructor includes the graduation year, adds enrolled courses, adds taught courses, and then prints all the data out. And when we run this code, we once again get identical output to what we saw in the previous example. This is the person version, the undergraduate student version, the faculty version, and the teaching assistant version of the output. To add the teaching assistant class to our Java example required us to make some small changes to the previously defined classes, but these were not drastic. However, to achieve a similar result in Ruby, we must learn about a new feature called Mixins, which use modules to achieve a form of multiple inheritance. Now, when it comes to Ruby classes, only single inheritance is allowed. But if you use modules, then you can inherit from multiple modules. However, the way this is implemented requires us to completely rethink our inheritance hierarchy. The reason that such drastic changes are needed is that modules cannot be instantiated. Only classes can be instantiated. So what we've done here is write all the modules in red and all of the classes in black. The red arrows indicate the use of Ruby's include keyword, which is how you incorporate a module into a class, though there are also other keywords to do this in different ways. There is no traditional inheritance between classes occurring here, although it is possible to combine class-to-class inheritance with module inclusion. So what we have is a module named hasName that has a method, name, and then another method, justName. This method will help make sure we are getting the correct version of the name we want as we override the name method in the learns and teaches modules. Person is a class which has a name. So this allows us to create a person with a name and nothing else. Learns is an entity that has a name, but also has a graduation year and can add enrolled courses as well as list those courses. This is why the student class includes the Learns module. The Teaches module only has add taught course and list taught courses. It has name via inheritance, although we will override it in this module. And an instructor is a class which includes the Teaches module. Then we have our new teaching assistant class that includes both learns and teaches. And you can see that among the modules, we have a diamond pattern of inheritance. Let's look at the source code. First, we have a listNames method, which is the same as we had in the previous Ruby example. And then we have our first module. This module is called hasNames. It defines an initialize method, which is a constructor, even though, and keep this in mind, modules cannot be instantiated. So a module cannot be directly constructed. But I can define a constructor that will be used by a class that includes this module. We also have justName, which combines the first and last name together, and then the name method simply calls justName. In later modules and classes, we will override name and then directly call justName in some cases. This end represents the end of the module. We then have our first class, which is quite simple. The person class simply includes hasName. It is as if we had directly copied the text of the hasName module into the person class. This is how the person class behaves. Next, we have the learns module. And notice that the learns module includes hasName. Therefore, learns will have a constructor, the justName method, and the name method. We add to that the graduation year method, the add enrolled course method, and the list enrolled courses method. We also override the name method. Specifically, the name method for an entity that learns is justName, meaning the version of the name without anything attached to it, combined with the class year converted to a string. JustName was also used in the list enrolled courses method here. In this particular case, we could just use name and avoid using the justName method. However, we'll run into problems later with the teaching assistant class that we can fix preemptively by simply using the justName method here. Now we have our second class, student, which includes the learns module. Now all we have to define in the student class is a new constructor. When we include learns, we're also including the initialize method that was defined in the hasName module. But we then define a new version of initialize that takes precedence and replaces it. Note also here that the learns module was referring to variables such as classes enrolled and class year that are only being initialized and assigned values in the student class once we reach its definition of the initialize method. Next we have the teaches module, which includes the hasName module and adds methods for add taught course and list taught courses, and also overrides the name method to include the job title before just the name. Next we have the instructor class, which includes the teaches module. And once again, all we have to provide at this point is a constructor, an initialize method for the instructor class, because the other relevant methods for the instructor class were already defined in the teaches module. Finally, we have our teaching assistant class. This includes both the learns and the teaches modules. And here the order is quite important. We want a teaching assistant to include the name instructor whenever name is referred to, and we do not want to show the graduation year. If we swap the order of these include statements, we would get the version of the name method from learns instead. We also define a constructor, and this constructor initializes all of the member variables that were initialized in both the student and instructor classes. So we have a small amount of repetition in the constructor here, but we are able to get the definitions of the methods defined in learns and teaches without having to repeat that code. Finally, we have code to test it, and this is the same for the person, the student, and the instructor. The only thing we have that's new is the teaching assistant instantiation, which includes a graduation year, mentions enrolled courses and taught courses, prints out the name, and then prints out both the enrolled courses and the taught courses. So when we run this, we get the exact same output we've received in all of the previous examples. So clearly the topic of multiple inheritance has led to a wide variety of different approaches in different programming languages. And the 3 languages shown here are merely a small sample of what's out there.